let's check out the solution challenge.
Let's do this.
Okay, I'll present my screen.
Welcome to the Google Developer Student Club's 2021 Solution Challenge. The mission of this challenge is to use Google technology to solve for one of the United Nations' 17 Sustainable Development Goals, aiming to end poverty, ensure prosperity, and protect the planet. Win cool prizes, mentorship from Google, and swag. Get help along the way from Google at training events, code labs, and hackathons. Submit your solution by March 31st, 2021. Register today. We can't wait to see what you build.
Let's get started.
Developer student clubs are university-based communities where students learn about Google technology and use their skills to solve local problems. Welcome to the Developer Student Club's 2020 Solution Challenge Demo Day.
I'm really excited about this summit because I get to learn a lot of new stuff, and DSC really helps me to identify and make my skills grow.
DSCs are university-based student groups that come together and learn Google technology from each other.
In DSC, I could not only learn about technical skills related about technology, but also here I could learn about soft skills like leadership, communication, and also mentoring.
I've been developing NLP-based web applications at school, and with the Google technologies I learned at the summit, I'm looking forward to taking my project to the next level.
We expanded developer student clubs this year to more universities and more countries across Southeast Asia. It is this summit where their journey begins. Over the next 2 days, DSC leads learn vital technical, problem-solving and leadership skills from Googlers and industry experts before they go back to their universities to train more students, build projects and contribute back to the community.
The most memorable part of this summit is when we met other DC leads from different countries, learning their culture and sharing the same goal, and that is helping our fellow students with the use of technology.
The sessions that was most useful for me was how to build community, how to focus and respect the audience.
It's crucial that students are able to see the big picture and prepare themselves for their professional career. And that's what DSC does. It gives them a path for the future.
The DSC journey helped me build my passion in one area of technology and grow my career.
We want you to start connecting with, understand your community, understand your university, see what's going on in your city, talk to businesses, talk to NGOs, talk to your university, identify problem statements, and then work as a group to solve those problems and actually build solutions.
I'd like to make sure that no one in my community is left behind.
We're so excited to work with you all DSC leads from across the region, to see your career grow and support you solve local problems and create impact in your communities.
Good day, everyone. For today, we're talking about Introduction to Machine Learning with TensorFlow 2.0. So, I'll just introduce myself. I'm Justine Clemente. Most people call me Justin. I'm currently working as an AI engineer at Senti AI, and also I'm a co-organizer of AI Pilipinas, the largest AI community here in the country. Then, while working full-time, I'm also pursuing my master's degree in computer science at the Salle University, Manila. So I'm an alumna of University of Santo Tomas back in 2019. So I'm almost 1.5 years into the AI industry right now, developing AI models, particularly in the field of natural language processing. So before we ask, or before I teach you guys how do machines learn, I'll teach you about, let's all first ask the questions, how do humans learn? So, paano nga ba natututo ang mga tao? Or paano tayo natututo? So, I have 3 little siblings, 2 boys and 1 girl, and watching them grow up, I see them learn, especially when it comes to recognizing or distinguishing these different colors. So how do people or how do humans learn how to distinguish these colors from each other? So as babies, they learn fast. So how do humans learn? So as we can see, we have our eyes, we have our vision, and in our eyes, we have the iris, the pupil, the parts of the eyes. So when the eye or pag may nakita yung mata natin na light, it reflects and then papasok sa optic nerve natin and nandyan yung mga wavelengths ng lights. So each color has different wavelengths. So if may makita tayong ganitong specific wavelength, ganitong kulay yung nakikita natin. If mas mataas naman yung wavelength na nakita natin, it means mas nagiging redder siya. So andyan yung color spectrum. I won't explain it further, pero that is the gist, like how we humans learn to distinguish these colors from each other. So to summarize, humans are able to distinguish these different colors based on their wavelengths. So another example. So watching them grow up again, I also see them learning how to distinguish fruits. This is a more complex one. Kasi each fruit has different shapes, has different colors. So, how do we distinguish these fruits ba? So, we can distinguish these fruits by color, by size, by weight, and etc. So, I just leave the question to you. So, lastly, so if we can see from the wavelength, we can learn how to distinguish colors as humans. From the color, the size, and the weight of the fruit, we can learn how to discriminate these fruits from each other. So, if makita tayo medyo oblong shape na fruit, it's nagkulay color green, it's a watermelon. If it's a round shaped fruit with color orange, it's called an orange. If may red naman around, it's an apple. If the size is small, then medyo red siya, it's a grape. So mga ganong stuff. So in machine learning, we call these features and we call these labels. So based from these features, the wavelength, the color, the size, the weight, we can distinguish or we can classify or we can predict ano yung mga nakikita natin, which are the labels. So in interactive, here we have a task of distinguishing animals from each other. How can you say that an animal is a bird, an animal is a dog, it's a cat? So I'll give you 20 seconds to think of something that makes these types of animal differentiate from each other. So mag-isip kayo ng mga features na kaya niyong maisip ng mga animals na pwedeng mag-distinguish from these 3 types of animals. So I'll give you 20 seconds for that. All right. So just a quick discussion lang. So if naisip nyo yung shape ng ear, it's one feature also. Kasi not all animals have ears. And sa cat and dog, different types of ears din sila. And if it can fly, of course, it's a bird. Hindi siya dog and cat. Another thing is yung colors or yung whiskers nila. So cats have longer whiskers compared to dogs. And dogs have, if they run fast, yung speed or yung kung ilan din yung feet nila. So of course, if apat, then hindi siya bird for sure. So mga ganong types of features, yung mga as humans natututunan natin how to distinguish these animals from each other. So since we know how humans learn already, then I can also discuss you how do we make machines learn. So it's almost similar as humans, but it's a more mathematical way because in computers, everything is mathematical. Even to the information, it's represented as bits, etc., etc. So first, can machines think? So kaya bang makapag-isip ng isang machine like a computer? So I'll leave that question to you already. Pero yung mga computer science student dyan, I guess your prof discussed this to you already. This question was asked in 1930 by the father of modern computer science, which is Alan Turing. So around 1930 to 1940s, if you guys watched the Imitation Game, he released a paper to consider the question, can machines think? So in-explain niya doon ano yung mga basic concepts how to distinguish a thinking machine from a machine that is just a machine. So he proposed the Turing test. So the Turing test is basically if a machine can fool a human into thinking that it is not a machine, then it means it is intelligent. So madaming types of tests to determine if a machine is intelligent, but hindi natin siya i-discuss ngayon since we're more on the practical part of artificial intelligence. So machine learning, what is machine learning nga ba? So machine learning is a subset of artificial intelligence. AI is machine learning, but machine learning does not represent AI in a whole sense. So madaming types of AI din na hindi machine learning. So back in 1950s, based from the paper na nirelease ni Turing, andyan yung excitement ng artificial intelligence na, uy, kaya ba tayo makagawa ng machine or a computer that is so smart that can help us in our daily tasks, right? So around 1970s to 1980s, around 1980s na, andyan yung Diyan ay nag-flourish yung mga theories ng machine learning. Nandiyan ay mga algorithms ng how do we make computers learn, which I will explain later. Then, back in 2010, nag-boom si deep learning. Deep learning is a type of machine learning. So, if you mention deep learning, it's always machine learning. Always remember that. So, deep learning is just a type of machine learning which uses a specific type of machine learning algorithms, which is neural networks, which we will use and later on to code a classification algorithm for recognizing types of flowers. So there are three main types of machine learning. So there's supervised learning, unsupervised learning, and reinforcement learning. So explain ko lang quick. Supervised learning is a type of machine learning that is learned by examples. And then, ang requirement niya, it's a dataset containing features and their corresponding labels. However, ang challenge dito, need mo ng annotation data. So if ever you have 1,000 images, kailangan may label kada image na yun. So if you want to classify 1,000 images of birds or of cats and dogs, then each image has its own label. So if millions yan, andyan yung challenge ng millions of annotated data. Of course, hindi naman lahat ng machine learning kaya need ng label. So there is unsupervised learning, so which is learning by discovery. Learning by discovery means it just finds a pattern on the dataset based on these features, based on the features that we have. Pero hindi niya kailangan ng label. So, ang challenges nito, it only arranges the data according to groups. Pero, it still need to rename these groups manually. So, it means after you train a machine learning model that uses unsupervised learning, it needs human feedback to reorganize or to fix or to check kung tama ba yung results nito at supervised learning na to. Kung tama ba yung na-learn yung patterns. So, the third one is reinforcement learning. So, it is learning by experimentation. So, requirement, it needs environment to be simulated. So, later, I will explain more deeply. So, parang positive reinforcement, negative reinforcement siya. Ganun yung parang sample ng reinforcement learning. So, challenges, it takes long time to train the model. So, mas matagal ang reinforcement learning kasi as humans nga, when we are learning through reinforcement, like yung mga positive, negative, nahirapan din tayo. So one example of supervised learning is called support vector machines. Explain ko later yung algorithm, but it is used to classify decision boundaries or to recognize decision boundaries given a specific series of data points. So makikita natin on this third column, the SVM or the algorithm learns the decision boundary or kaya niya nakakapag-learn siya ng separating line from the red and green points, which are labels. So, for supervised learning, based from this GIF here, nakikita niya na kinaklasify niya based on colors, yung mga patterns na nakikita niya sa dataset. So, ito kunyari, color green, magka-group yan, same pattern yan, it means same classification siya. Pero features lang yun naman niya. And then for supervised learning, here we can see an AI agent that is learning how to walk. So, I won't explain yung unsupervised and reinforcement, but for this talk, I'll just explain supervised learning. So, applications of machine learning. For supervised learning, we have self-driving cars. For unsupervised learning, we have Google News. Di naman natin need ng labels to classify or to group news. We can group news based on the words that are given in a news article. And then for reinforcement learning, so OpenAI 5. If you're not familiar with OpenAI 5, OpenAI 5 is an AI agent that learned how to play Dota 2. So back in 2018 ata or 2017, it beat the world champions in the TI8 ata or TI7. So, and it's an AI that learned how to play Dota 2 and nakabit sila ng world champion. So yan yung one practical application of reinforcement learning. So reinforcement learning is also used in human games like chess, Scrabble, tic-tac-toe, Go, and other games then. So mostly if you see an AI that is playing games, that is able to play games like chess, it means mostly common na reinforcement learning yung algorithm na gamit. Then, supervised learning. Proceed tayo sa supervised learning. On a mathematical note, we have an f of x. We have a function given x, which are the features, and y as the labels. Features, ang x. And then, yung function natin is the machine learning algorithm or algorithms. So, labels, ito yung ground truth natin. Since sabi ko nga, need ng annotated data. So, ito yung on the supervised learning. So, on a mathematical note, given features x, we want a machine learning algorithm to learn the function x that maps to the labels, that maps to y. So, given features x, we want to find a function f of x that maps these features to their respective labels. So, ano ba yung process ng supervised learning? Here, we'll get more deeper on supervised learning, so please prepare yourselves. 5 seconds. Alright, so given features and labels, a mapping of features and their corresponding labels, i-divide natin into training set and the test set. unobserved data. So test set is used later to test the accuracy ng machine learning algorithm natin on unseen data. Kasi yung training set, it is used for training the machine learning models. So if you want to test our machine learning model, syempre, itetest natin siya on data that is not seen. It's just like parang in school, pag tinurututuan tayo ng prof natin, ng mga kunyari, sa calculus, sa algebra, sa math, nagpapa-secret siya, nagpapa-assignment siya, yun yung training. Tapos yung test natin is yung mga exams. Yun yung unobserved data. So unobserved data is used to know kung maganda ba yung performance ng machine learning algorithm natin. So, papasok yung so ita-train na natin yung training set, ipapasok natin siya sa machine learning algorithm. X-train, Y-train. So, train the machine learning model on the training set. So, once it is trained, meron na tayong learned algorithm, meron na tayong given function. So, using this trained model, we will test it on the test set. So, yung machine learning algorithm, meron tong nilalabas na predictions. So, i-evaluate natin siya. Yung performance ba ng machine learning algorithm compared sa y-test, accurate ba or not? So, we compare yung prediction ng models with its true values. So, for example, if we train a model on cats and dogs, then bibigyan natin siya ng 10 pictures. So, na-recognize niya correctly 8 out of 10 doon. So, it means it is 80% accurate. Kung na-recognize niya 9 doon, it is 90% accurate. That's how supervised learning works in a very easy way na hindi ko kayo tinuturuan ng math. So, this is how the basic machine learning process is. So, do note that in supervised learning, we need annotated data. We need labels. Right? So, moving on. One of the common algorithms that pinaka-basic is k-nearest neighbors. So, it is classified based on similarity and k-nearest neighbors. So, ano ba yung similarity? Explain it later. So, if k is equal to 1, it classifies based on the closest data point. So, if nag-take kayo ng math classes nyo, so sa algebra, may mga distance metric tayo, may distance formula. So, in computer science, may iba't ibang distance formula tayo. May Euclidean, may Cauchy. So, iba't ibang functions din. So, ang k-nearest neighbors, wala siyang training in a sense. Explain ko later kung bakit. So, andito yung curse of dimensionality. Explain ko din later. So, ito yung mga sample distance formula natin. So, I guess some of you are already familiar with this. So, ito. So, ito yung GIF. So, given k is equal to 5, ang k natin is equal to 5, we want to classify the color black point. So, currently, pag 5 nearest neighbor siya, ang malapit sa black is 3 green, then 2 red. So, syempre, mas madami yung green, so kulay green yung classification ng black. Pag tinaas natin yung k to 7, so, makikita natin na pag tinaasan natin ng 7, according to the GIF here, is magiging red na siya. So, hindi siya brown, red yung nakita natin dito. So, ayun lang. So, kaya hindi siya need ng training kasi wala naman tayong function na nila-learn. Ang ginagawa lang natin, kino-compute natin yung distance between the test point, which is the color black, to the other points, which is the red and green points. Tapos hahanapin natin kung ano yung mga malalapit sa kanya. So, if mas malapit pag k is equal to 5, color green, 3 yung green, 2 yung red, so 3 is greater than 2, so color green siya. So, kung ano yung majority vote lang. So, for curse of dimensionality, ang meaning lang dun is pag tumataas yung dimensions ng features natin, dito kasi, 2 lang yung features natin, which is x and the y-axis. So, pag dumadaan siya 3-dimensional, 100-dimensional, it's a mathematical problem already na ang mangyayari is yung points, magkakalapit na sila. Sobrang compact na, in a way, na mahirapan na si k-nearest neighbors dito. So, usually, may mga algorithms naman that reduces the dimension of the features pero hindi ko na siya explain here in this talk. So, ayun lang yung meaning ng curse of dimensionality. It means na wag mo gagamitin si k-nearest neighbor if you have a data set or marami kang features na ginagamit. So the second algorithm that we're gonna be talking about is support vector machines. So before deep learning, before neural networks, support vector machines is one of the most used algorithms for machine learning. So ang SVM is find the hyperplane that best separates the two classes of data. So if nakita niyo yung GIF earlier sa supervised learning, it's support vector machines like what I said earlier. So hinahanap lang niya yung decision boundary na nagseparate ng two classes of data. So it's a very complex algorithm. Simple lang siya dito. Pero if you want to search on it more, madaming tutorials sa internet about this. Pero here's the simple explanation of how SVM works. So may tinatawag tayo kernel trick. So it transformed the data into a higher dimensional space if wala tayong mahanap na hyperplane. So makikita natin dito, two-dimensional sa right side, two-dimensional lang yung data. We have the x and the y axis. Kaso wala tayong mahanap na hyperplane. Kasi if makakahanap ka ba ng line na nag-separate best ng two data na to? Hindi, di ba? So ang ginawa ni SVM, gumamit siya ng kernel trick. Transform niya itong two-dimensional data into a three-dimensional data para makahanap ng separating hyperplane, which is on the left side, nakita nyo, nakahanap na tayo ng separator for the green and the red points. So, I won't explain yung equation further kasi sobrang complex nitong kernel trick na to, pero that's how it works lang. It transforms a data into higher dimensional space para makahanap ng hyperplane. If it transform na niya, then wala pa siyang mahanap, edi ita-transform na siya ulit into into a more higher dimensional space. So, then itong convex optimization, medyo important to for machine learning because this is how we train algorithms. This is how we learn yung mga separating hyperplanes dun sa SVM or sa neural networks. So in supervised machine learning algorithm, ang goal natin is to minimize the error between the predicted values and the mean values. So ito yung loss function ng SVM. Yes, if you guys want to learn machine learning, hindi need na magaling kayo sa math. It's just that you need to appreciate math more. Kasi madami talagang math here sa machine learning. So, ito siya. So, ang ginagawa lang niya, technically, machine learning is just a bunch of trials and errors during training. Kung mali yung, it learns from mistakes. It learns from the mistakes niya. Again. So, ayun yung cost function niya. So, ang need natin is pababain yung error or yung cost function. So, nakita niyo here, bumababa siya, it reaches a minimum, local minimum. It reaches a global minimum since parabola siya. It's a parang quadratic equation. However, in practice, hindi lahat niyan parabola. May iba na parang hill climb or parang hills na maraming curves. So, ang ginagawa ng context optimization is minimize the error for the loss function. So, kada algorithm, kada machine learning algorithm, iba't iba yung loss functions niya. Hindi lahat yung isa. However, pagdating sa neural networks, medyo may mga dalabas na doon yung common types of loss functions. Pero pagdating sa mga algorithms before neural networks, kada algorithm has its own loss function. Again, if wala kayo nakikitang loss function ng k-nearest neighbors, kasi hindi naman natin need ng loss function for the k-nearest neighbors. Kasi hinahanap lang niya yung mga nearest neighbors is in the distance formula na binigay natin at yung number of k kung ilan yung nearest neighbors niya. So let's move on to neural networks. What is neural networks? Neural networks is inspired by how human brains work. So it is very powerful, but it needs heavy computational resources. Later, explain ko kung bakit need ng maraming computational resources. So ito yung brain. So we have the human brain. It is in the top. So may dendrites, may nucleus, yung ating brain. Then may axon. Axons are the connections between two dendrites or parang axon terminals. So sa perceptron, basic neuron, tinatawag siya. It is a single neuron that mimics how the brain works. So may bunch of inputs, papasok siya dito, then may output siya. Ganun din naman yung brains natin, may input yung dendrites, papasok sa axon, then mag-output siya here. Or vice versa. Pero our brains is composed of billions of neurons. Ito, parang isang neuron lang. Pagdating sa human brains natin, billions of neurons siya. So, maraming connections. So, sa neural networks, ganun din. So, from a single perceptron, may tinatawag tayong multi-layer perceptron. So, makita natin from here, we have migrated here. Each circle it's called a neuron. So, we have an input here. Input here are arbitrary values or a matrix. Then, it is connected to the next neuron, which is called the hidden layer. So, pwede ding hindi lang neural networks to, pag tinawag na deep learning, meaning marami lang siyang hidden layers. Kaya siya tinatawag na deep. Kasi pag madami hidden layers mo, the neural networks goes deep. Kaya siya tinawag na deep learning. Then itong hidden layers, connected siya sa output layers. Then each of these neuron has a node. So may mga tinatawag siya na weights. Ano, W1 for 3. So itong A3, input 3, is connected to the fourth hidden layer, which is may weight siya. May corresponding connection yan. So yung weights na yan, tinatrain yan through context optimization in a simple sense. Pero if you guys are interested, paano natin nakukuha yung output, I'll explain it. So, ang goal natin is from input, we propagate forward para makuha ng output. So, sabihin natin we have an input, sabihin natin arbitrary values lang, random values. So, ito, A1, may connection siya here. So, may weights. Ang ginagawa lang niya, if familiar kayo with the dot product, so, tina-times niya lang, W11 times A11. So, meaning, W from here, W11 times A1. So, may value to, may value din to, ito, times ito, plus W12, value nito, times ito. So, parang summation lang siya of the dot product between the connections and the value of the neurons. So, pag nakuha na natin yung Z12, excuse me for that, pag nakuha na natin yung Z, which is called the logit, tawag natin dyan logit, ipapasok natin siya into an activation function. So, sa neurons natin, if familiar kayo how brains work, may mga neurons din na nag-activate. So, yung activation function na yan, nagde-determine if yung na-compute ba natin na value based on this dot product, mag-activate ba tayo based on the value that we obtain. So, if mag-activate siya, then yes, the neuron is activated, makakuha tayo ng output. If not, it's false. So, itong loss function na to is called a sigmoid function. Sigmoid is just a function to determine if a given input is 0 or 1. So, binary lang siya. Tinatawag na binary classification kasi true or false lang ang output niya. So, ang ina-output na itong sigmoid, pag pinasok mo to, if you want to derive this equation, ang value lang niya is between 0 and 1. So, paano natin malalaman is true or false. So, pag pinasok natin itong dot product based from this, pag pinasok natin ang dot product based from the summation of and the dot product of these values, pag pinasok natin siya sa sigmoid, greater than 0.5 yung in-output niya, then it means it is true. Pag it's less than 0.5, it is false. Nandyan yung threshold value. Then, ito yung sinatawag kong loss function of the neural network, which is the same na kino-compare natin yung predictions ng model, which is the A12. Ito yung predictions niya, minus the true value of the given input. So, kaya siya supervised learning pa rin, in a way. Pero, recent advancements, may mga unsupervised learning na neural networks, but I won't discuss this here. Basics lang muna tayo. So, ini-square natin siya kasi ito yung type na loss function that uses mean squared error. Madaming types of loss functions. Pagdating sa neural networks, iba't ibang loss functions din yan. Depende sa ginagamit natin na dataset and ano yung task na ginagawa ng neural network. So, ayan o. So, this is called the activation function. Then, this is called the loss function. So, if may weights tayo, paano natin nakukuha yung weights? Paano natin nakukuha yung weights na itong model? Since lahat tayo nagre-rely lang here. Since ito, A11, itong mga neurons na to is based lang from the weights din here. So, yung weights natin, tinatrain siya using back propagation. So, dito na gumagamit, dito na yung heavier math na nangyayari, na gumagamit na ng calculus, linear algebra, yung neural network. So, makikita natin sa equation here, gumamit siya ng differential equations, hindi ko siya explain further, hindi ko din i-derive. But if nag-output tayo, nakita natin from the loss function here, kasi pag kunyari tayo as humans, may ginawa tayong bagay, if mali yung ginawa natin, we learn from mistakes. Si neural network, ganun din. From the mistake that you have learned, may value yun. So if malayo ba yung prediction ko sa true value, then mas malaki yung loss niya, mas malaki yung cost niya. Then if meaning pag papalapit yung predictions ko sa true value, bumababa yung loss functions niya. Context optimization. We find the minimum error na kayang mabigay ni neural network. So, from the output, babalik naman siya, pabalik. So, kanina nag-forward tayo, gumamit tayo ng dot product. Ngayon, babalik tayo using this formula. So, ito yung mga weight updates na sinasabi. So, if you want to update the weights of this W13, ito yung equation niya. Alright? So, ito yung tinatawag na parameter update. So, meaning, then, these weights of the neural network are also called gradients. Always remember that. If you want to dive into neural networks, these are called gradients. And it is updated through parameter updates or through context optimization. And then, ayan na, daming math, right? So, I didn't explain, di ko din derive sa inyo yan. Kasi sobrang time consuming nag-derive or ituro ang mathematical sense na ritual pa. And it's hard because this is also recorded. So I'll just try my best here na explain siya in a simple sense. Madaming tutorials out there sa YouTube. I'll share some links later if you guys want to learn more how this neural networks really work or how machine learning really works. So, ito yung example na neural network pag nag-training siya. So, una, mag-forward siya from the prediction, then mag-back propagation siya to update the weights. So, yung weights na yan, it is arbitrarily started as a random value. Then, at some point, through convex optimization, nag-converge siya. Like, nakikita nyo kanina, nag-minimize siya. So, it will converge at some value already. Alright? So, ayan, I guess nakita din yung GIF. So, in terms of model complexity naman, like what I said earlier, pwede mo padamihin yung hidden layers mo dun sa neural network. However, pag dumadami yung hidden layers mo, nagiging complex din yung model. If konti lang naman yung layers mo, meaning if the dataset is too complex for a machine learning model, it means nag-underfit siya. Nandito yung terms na underfitting and overfitting. So, if your model is too simple for a too complex task for a dataset, it underfits. If it's vice versa, if your model is too complex for a simple task, it overfits. So makikita natin dyan, paano natin mag-determine yun? We check the errors dun sa training data and sa test data. Later, makikita niyo yung ganyang types of plot in practice. So hinahanap natin, as the model complexity increases, nakita niya na bumababa pa rin yung error, pero tumataas na yung error on test data niya. Bakit? Kasi pag nagiging complex yung model mo, mas madali niyang ma-memorize. Ang nangyayari, minememorize na lang niya yung dataset. So pag minememorize mo, para kang nag-exam sa math, minemorize mo yung ganitong types kung paano isolve itong bagay na to, pero hindi mo inintindi. Pagdating sa exam, babaksak ka. Kasi minemorize mo yung ganitong topic, minemorize mo lang siya. Pag na-encounter mo ganun, in the future, alam mo siya, pero dahil memorize mo, hindi dahil naiintindihan mo. Pero pagdating sa exam, babaksak ka. Kasi hindi mo siya naiintindihan, minemorize mo lang siya. So, ganun din yung neural networks. However, if too simple naman yung algorithm mo for a complex dataset, hindi makikita natin na kaya pa niya. If you make the model too complex, or if you increase the complexity of the model, mas kaya pa niyang mag-learn. So, ang hinahanap natin is this sweet spot, yung ideal range for model complexity. Want to find a not so complex model, but not so simple model that learns best on our given dataset. And this is done through experimentation. Mag-experiment talaga tayo. So, again, before we proceed further, medyo nagiging technical na tayo, but as one of the pioneers in the AI field, sabi niya, don't worry about it if you don't understand. So if you search Andrew ng sa YouTube, sa Google, he's one of the best AI educators out there. Sobrang galing niya mag-explain ng mga machine learning algorithms. So I highly recommend him if you guys want to learn more about machine learning. Kasi sa kanya din ako natuto before. So, nandito na. Tapos we're done with basic machine learning. I explained to you how neural networks work. So, nandito na tayo. Nandito na tayo sa the rise of deep learning. So, the rise of deep learning before, may traditional machine learning flow natin, may input tayo. We have, from the input, we have an algorithm that extract the features. Then from that, na-obtain natin yung features. Then we train a machine learning algorithm, SVM, KNN. Though di natin SVM, pero support vector machines, basic neural networks, then may output siya. Now, using deep learning, using neural networks, kaya na niya na isang model lang. Kaya na mag-extract ng features and use machine learning at the same time. Dati kasi back in 1990s and 2000s, yung mga other machine learning tasks need pa ng feature extractors. Pero using deep learning, hindi na natin kaya na we can feed raw data mismo dun sa deep learning algorithm that it can learn. So, for example, yung image na to, is this a cat or dog? Sorry. I have to pass it sa neural network like what I explained earlier. Then babalik siya here. So, ayan yung tinatawag na deep neural network. So, what I explained earlier, deep learning is just neural networks, pero it's just madaming hidden layers. And may mga special equations yan. So, explain to me, later. So, back in 2010, 2013, 2012, yeah. As far as I remember, 2012. Nilaunch yung ImageNet Challenge. So, the ImageNet Challenge is given almost 1.5 million images, then 1,000 labels, 1,000 object classes. Create a machine learning model, create a deep learning model that can classify this type of task. Then, parang ganun yung challenge na gawa ka ng machine learning model, gawa ka ng deep learning model na kaya makapag-classify ng ganito karaming dataset, ganito karaming dataset, ng maraming ng mataas yung accuracy or maganda yung performance niya. So, currently, ang ImageNet challenge or ImageNet dataset is around millions, 14 million, 15 million of images na. Pero nagsimula sila around 1.5 million. So, maraming dataset talaga. Another thing to note pala, if you guys are gonna use deep learning model, matakaw si deep learning sa dataset. So, if you have a dataset pero konti lang siya, around 100 lang, around 150, 200, hindi siya umabot ng thousands, then consider not using deep learning if hindi naman ganun ka-complex yung dataset mo for deep learning. Kasi konti lang siya, matakaw si deep learning sa dataset, nakita niyo mathematical equations niya. It needs that much data to learn or to have a good performance. So, if nako-content kayo sa dataset nyo, kuha po kayo or dagdagan yung dataset nyo. Ganun dapat siya. So, ito yung one of the most used back then in the ImageNet challenge is convolutional neural networks. Convolutional neural networks are a special type of neural networks. So, neural network pa rin siya. Assume the same equation that we're using earlier. May backpropagation pa rin na nangyayari. Ang difference lang is how it works. So, given an image, usually it's used in image. An image is just a matrix, right? RGB. Though makikita mo dyan, based from this GIF here, RGB lang siya. Then neural networks are special type of neural networks that transforms these images using convolutions. So ang ginagawa lang niya, ayan yung may mga kernel filters. So if you want to learn more on here, yung pinaka-technical stuff how it works, search nyo lang, convolutional neural networks, madaming tutorials dyan. Pero, siyempre, RGB to, matrix lang ang isang image. So, based from this, parang neural networks learn this type of representation. Later, on our example sa TensorFlow demo, we will use this type of neural network to classify flowers, images of flowers. So, ayan. So nakikita nyo sa isang convolutional neural network, hindi lang basta-basta na isang convolution lang ang kailangan. So kailangan after ng convolution, pwede natin dagdagan pa ng mas maraming convolution. So ang ginagawa lang niya is given an image, it convoluted the data, it transformed the data into a numerical representation, yung raw matrix natin na image, it transforms these images or yung mga laman ng images through convolutions into a good numerical representation in a way. So, after ng convolution, plus ReLU is an activation function. So, after neto, papasok siya sa pooling. So, makita nyo dito, meaning ng pooling is like kinukuha lang yung mga maximum values in these matrices. Then after that, pwede mo padagdagan ng isa pang convolutional layer. Then dagdagan mo ng pooling. Then after that, flatten. So ito na yung mga magiging flat neural network na siya. Like yung pinakita ko kanina, neural network. Then papasok siya dito, fully connected. Meaning lang ng fully connected, each node, each neuron is connected to all of the neurons in the next layer. So then papasok siya sa activation function. That is a classification activation function. Softmax is just a sigmoid function. Pero ang sigmoid kasi 0 or 1. Ang softmax, maraming labels na kaya na mag-classify ng maraming labels. So, ayan. So, based on an image, na-classify niya if car, truck, or van, or anong type ng vehicle siya. So, ganun yung ginagawa ng convolutional neural networks. So, sa ImageNet Challenge, back in 2010, ito error to hindi to accuracy. Let me be clear with that lang. So meaning, pag mas mataas yung error mo, like what I said earlier, mas pangit yung performance ng model mo. So around 2010, ito yung shallow neural network, meaning mga one hidden layer neural network lang. Hindi pa siya deep. Wala pang deep learning masyado nito. Then, pagdating ng 2012, andito na si AlexNet. So nakita niyo yung decrease ng error. From 25.8, it dropped around 10 points in terms of error. So, mas kumunti yung error niya dun sa dataset, 8 layers. And then, the next year, bumaba pa rin. 5 points lang, pero 8 layers pa rin siya. Then dito, naging 19 na, halos double 2 times. More than 2 times, BGGNet. Then, si GoogleNet, made by Google. However, from 22 layers, dito na pumasok yung sobrang deep learning, umabot na ng 152 layers. So, baba na ng error niya. 3.57 na error na sobrang lapit na sa 0, which means this model has a good performance already. So, ResNet is a residual network. Tawag sa kanya residual networks. I'll shade it further, pero nakikita niyo naman layers niya. Sobrang dami na ng layers niya. So, sipin mo, you repeat that back propagation equation many times based on the layers that you have. So kaya ako sinasabi na maraming computational resources na need sa deep learning or sa neural networks kasi madaming equations na nangyari in terms of training a neural network. So beyond image classification, I know as student ako, I'm a big fan of the startup Korean drama series. So makita natin or napanood niya na gumamit sila ng object recognition doon, hindi lang neural network nila hindi lang capable of classifying a given image. Kaya niya mag-localize. So, kumbaga, hindi ko lang kaya mag-recognize kung ano yung nasa image na to, but I can point to you where in the image exactly the object is. So, object recognition tawag dito. However, hindi naman perfect yung mga models na ganito, like what you see in the GIF here. Like, in the series, di ba? Parang naklasify yung father ni Namdo-san na as toilet. So, ang reason ni Namdo-san dito, kasi daw masyadong malapad yung unang father niya, yung light nagre-reflect dun sa image. So, yung toilet kasi usually kulay puti din. So, parang ganun yung nangyari. So, it means this is an error recognition. However, nakita naman din natin kung napanood niyo yung series, nakagawa sila ng self-driving car using these types of algorithms. So, aside from classifying images lang, currently, yung mga neural networks ngayon are powerful enough to even drive a car. Like yung ginagawa ni Tesla. Yung ginawa ni Tesla, it's an AI model, neural network ang gamit nila. It's called HydraNet. So, gumagamit sila ng object recognition on that, image recognition. Hindi lang niya nito-classify, but it can localize. So, I can point to you where the next car is, kung asan yung mga kotse na nakikita ng camera. So, ayan yung mga gamit nila. But remember, hindi lang, as far as I know, hindi lang camera ang gamit nila. May mga extra additional sensors pa sila na ginamit here. So, deep learning was proposed in the 1990s. Totoo to. Bakit ngayon lang siya nangyari? So, yung neural networks actually was proposed or was yung naayos yung algorithm around 1990s. Pero nakita nyo kanina sa chart ko, around 2010 lang siya nag-boom. Bakit? So, there are a few reasons for this. Isipin mo, if you create this neural network or yung mga equations na pinakulta ko kanina from scratch na basic programming lang gamit mo Python, mahirapan ka. Especially if maraming layers. Like sa deep learning, pag sobrang dami mong layers, ang dami mong need i-code nun na equation. Right? So ngayon, we have frameworks and tools already that we can use to implement these neural networks easily. Andyan si TensorFlow, andyan si scikit-learn, andyan si PyTorch. So first, explain ko sa scikit-learn. Scikit-learn is a machine learning library in Python. Hindi siya neural networks, but it is focused on SVM, k-nearest neighbors, and mga other basic machine learning algorithms, mga traditional algorithms natin. However, may neural network din siya, pero hindi siya deep, hindi siya CNN, basic neural network lang, like yung pinakita ko earlier. And then, nandito sa TensorFlow and PyTorch, pumasok dito yung tinatawag natin na GPU computing. Scikit-learn kasi can only compute or train the model on CPU. However, pag pumasok si TensorFlow and si PyTorch, iniload na niya or tintrain na niya yung model using GPU. If makikita kayo, if yung mga GTX, RTX 3060, if nag-build kayo ng PC, if familiar kayo sa mga Turing architectures, yung mga minamarket ni NVIDIA na mga AI GPUs. So, kaya siya need, kasi using TensorFlow and PyTorch, we can train our deep learning models faster kapag train natin siya ng GPU. Kasi GPU yan eh. We already know that GPUs are already faster than CPUs. Ang difference lang ni TensorFlow and ni PyTorch is technically, I won't explain the deep na, pero PyTorch is made by Facebook, TensorFlow is made by Google. So currently, I know both. I know these three libraries. Ako kasi I'm leaning towards a framework agnostic developer. So each of these frameworks kasi have their own strengths, have their own capabilities, advantages and disadvantages. So for me as an AI developer, it's good not work to use these kinds of frameworks based on the current problem na in-handle ko na, may binigay sa akin na task. Mas better na if you use PyTorch on this. May another task, mas better na if you use TensorFlow. So each of these frameworks has its own strength. Pero for beginners, if you want to learn, if you guys want just to deploy machine learning or deep learning models nang hindi kayo masyadong nahihirapan, I suggest you guys use TensorFlow. Although mas madaling mag-build ng ML models kay PyTorch, pag magde-deploy na kasi kayo ng machine learning models, mas madaming support si TensorFlow. Kasi mas naunang i-release TensorFlow before kay PyTorch. So, yeah. And then the second one is yung computational power. Like what I said earlier, dyan na lumabas yung GPUs natin. So, syempre, noong 1990s, wala pa namang GPU nun. Alam mo naman natin yung mga types of computers na ginagamit pa back then. So ngayon, may GPU computing na. We can already train our AI models on these devices. And then, if familiar, like what I said earlier, so OpenAI 5. So train nila siya on 256 Tesla P100 GPU sa Google Cloud Platform. So, if makikita nyo, ito yung parang gaano ka-costly mag-train ng isang AI model. Well, si OpenAI 5 kasi, malaking machine learning model talaga siya. And sabi ko sa inyo, matagal mag-train ang reinforcement learning. So, reinforcement learning kasi gamit nila here. So, ayun yung mga ganitong grabe, yung mga malaking deep learning models na ginagamit ngayon. So, like sabihin natin yung kalanamdosan. Yung kalanamdosan, siguro explain ko lang ng konti. Yung kalanamdosan, for sure, it is trained on GPU din. Nakikita nyo naman, sobrang real-time nila mag-train doon. So, yung mga ganong stuff, need nila ng GPU dati. So, usually, hindi mo naman need bumili ng maraming GPU. but rather, you can rent these GPUs sa cloud. So, if familiar kay Google Cloud Platform, AWS. So, yeah. So, ako kasi usually, wala akong mahina din GPU ako sa laptop. So, usually, I just use Colab, which we will use later on. So, later, hindi nyo need ng GPU para makapag-train kasi we're gonna use a remote a website that we can train our AI models on. So, may GPU siya. It has a free GPU already that we can use. Pero hindi naman natin, hindi siya pwedeng laging gamitin kasi may limits din yung usage. So, ayun. And then, another thing is sa cloud computing. Like what I said earlier, kahit na pangit yung laptop mo, if you know Google Cloud Platform, you can rent the GPU on that. Then you can just launch your compute engine on that. Tapos, ayun na, you can load na a Jupyter Notebook, your personal environment na gusto mong gamitin, Python environment, and other stuff. So, we can easily share data thanks to this guy. So, may nakakilala ba sa kanya? So, if walang nakakilala sa kanya, this guy is Tim Berners-Lee, the creator of the World Wide Web. Back in 1990s, isipin mo, if nag-deep learning model sila doon, paano kayo nakakapag-share ng data, ng malalaking data? Isipin mo, papadala ko pa yung mga malalaking disk na yung mga malalaking memory. Mahirap. So, due to the invention or due to the creation of the World Wide Web, we can easily share data already. Madaming data na nasa internet that we can use for machine learning, for artificial intelligence, that we can train our models on to do a specific task. Like, andyan si ImageNet. Si ImageNet, nilaunch din siya online. Nilaunch din siya to cloud. So, yung dataset niya online din. So, from that, that's our introduction to machine learning na. Our next topic will be machine learning with TensorFlow already. I guess take this time for a break muna. So, yeah, I'll be back in a while. All right, so we're back. I hope you had a good break. Kahit 3 minutes lang siya. So for now, I'm gonna introduce you to TensorFlow. So let's proceed. What is TensorFlow? Ano nga ba si TensorFlow? So TensorFlow is an open source library that is used for machine learning, created by, as I've said earlier, it's made by Google. So it's mostly used on training and inference of deep neural networks. You can also implement other machine learning algorithms, but nandiyan na si scikit-learn for that. So for deep neural networks, GPU computation yung need niya. So kaya ginawa si TensorFlow. So meaning ng TensorFlow, or where does the name TensorFlow came from? Tensor is a representation of multi-dimensional arrays, and flow means computation graphs. So later, share ko how these tensors flow in the library itself. So it is available on Python and C API. So currently, I use TensorFlow on Python since Python yung language na alam ko for building machine learning models. So may mga other AI developers or researchers na gumagamit ng C kasi mas mabilis siya in a way. Pero since it's production level, mahirap naman i-productionalize C. So ako, I use Python for easier production. So it is also available on C++, Go, Java, and JavaScript without the backwards compatibility, without the API backwards compatibility. So why do we need frameworks such as TensorFlow? So bakit nga ba natin kailangan si TensorFlow? So as I've said earlier in our presentation, ang hirap i-develop ng mga models na to, and we use TensorFlow to develop new ideas. So dahil we have already a library for creating deep learning models, mas madali yung trabaho natin as AI developers. So, it automatically compute gradients, or automatic na yung back propagation niya. Ibigay mo lang kay TensorFlow kung anong equation, or kung gusto mo custom equation, pero pagdating sa mga back propagation, may mga equations na sila na preset na you can call just by a function. So, kanina, GPU computation. So, dati, mahirap i-run sa GPU yung mga programs natin since lahat ng CPU server lang. Now, using TensorFlow, may extension din siya, or it runs on CUDA. If familiar kayo kay NVIDIA GPU, CUDA yung gamit nila to run these tensors on the GPU itself. So kaya need siya ng GPU. So TensorFlow is currently compatible lang with NVIDIA GPUs. AMD, I have not heard of it yet, pero NVIDIA yung gamit ko sa GPU for training. But usually, I train my models on the Google Cloud. So why TensorFlow? Bakit nga ba ginagamit natin si TensorFlow? So TensorFlow is an end-to-end open source platform for machine learning. It has a comprehensive, flexible ecosystems of tools, libraries, and community resources that lets researchers push the state-of-the-art in machine learning, and developers easily build and deploy machine learning-powered applications. So yan yung design philosophy ng TensorFlow. Easy model building, robust ML production everywhere, and powerful experimentation from research. Easy model building, we can build our models easily using TensorFlow. Our robust machine learning production, hindi lang training, but rather if you want to deploy our machine learning models na magagamit ng tao, we can use on our mobile applications, andyan is TensorFlow. So powerful experimentation for research, ang dami niyang support for experimentations ng mga deep learning models natin. So mas mabilis tayo makapag-publish ng research, mas maraming na-develop or na-innovate na AI. So ano ba yung TensorFlow ecosystem? So ito yung TensorFlow ecosystem. We have the TF data for the datasets. We have our keras for high level, or estimators for low level for building our machine learning models. Then we have our TensorFlow hub. So para siyang repository for models. So if you want to serialize, you want to wrap our model into one file na pwede natin gamitin and pwede magamit ng ibang programs, ganun siya. So we have our training distribution strategy. We have CPU, GPU, and TPU. If you have not heard of TPU is Tensor Processing Unit. So it's parang it's higher level than GPU that is focused on computation. So analysis, we have the tensor board. So parang visualization tool lang siya. So from the safe model, pag na-serialize na yung model natin after training, if you want it to be deployed, we have TensorFlow Serving, TensorFlow Lite for mobile applications for Android, iOS, and Raspberry Pi. We have TensorFlow.javascript or TensorFlow.js for our web browser or for web apps and Node.js. So other languages, bindings, like yung sinabi ko kanina, may other supported siya na languages. But itong mga to, remember, if you want to use TensorFlow on browser or using .js or other languages, remember na dapat yung model natin, na-train na natin siya. So meaning, ito, gamit siya on Python. We can use Python or C APIs for this. Pero usually, yung C, Java, Go, C#, Rust are yung mga safe model or yung mga na-train na model siya. So in this talk, in this introduction, we're gonna only focus on this. We have the data design and model design using TF data and Keras. So, ang design philosophy ng TensorFlow, from research to production, then we can deploy it everywhere. So, on the community side, TensorFlow empowers responsible AI, and since it's open source, it is powered by community. So, TensorFlow is one of the earliest frameworks, actually not earliest, dito pumasok yung mga GPU computation at easier design, easier writability, and readability when building AI models. So first, before papasok tayo sa TensorFlow, explain ko muna yung computational graphs. Ano nga ba ang computational graphs? If you guys are using TensorFlow, lahat ng nandito, lahat ng processes is made by computational graphs. Is powered by computational graphs. Deep learning frameworks such as TensorFlow, PyTorch use computational graphs to build neural networks. Hindi ko na-explain yung difference sa kanila, but may major difference in terms of their design philosophy in a way. So computational graphs are defined as a directed graph. So if familiar kayo sa graph na data structure, directed graph lang siya. So directed siya, so it goes from left or right, depende dun sa direction ng graph na yun. So where the nodes corresponds to mathematical equations. So computational graphs are a way of expressing and evaluating a mathematical expression or expressions. So example, let's transform the following equation to a computational graph. So if you want to transform this function x plus y times z to a computational graph, ganito yung transformation niya. So makikita natin si x and y. So since we're following the PEMDAS rule here, mauna si parentheses. So x plus y, so may sum siya, which is p. So ita times natin siya kay z. Then ito na equal ng j. Ganyan yung computational graphs niya. So sa neural networks, ganito din siya. This computational graphs, ganito yung nangyayari. How the equations or mga computations sa TensorFlow are represented in Python computational graphs. So more examples. So if you want here, so we want to do this line of code in TensorFlow. If we execute this, pero hindi siya TensorFlow, it's just basic Python. Pero let's imagine na we're gonna do this in TensorFlow. So A is equal to 5, B is equal to 15. May product siya, A times B, sum is equal to A plus B. So ang result, we divide the product by the sum, then ipiprint natin yung result niya. So ganito siya. So si multiplication, si product, may galing sa A and B. So if we want go here, papasok sa multiplication, then may product. Then si add din, A plus B rin, galing din kay A and B. So may sum din siya. So we divide the product and sum, then may result. So as you can see here, ito, yung mga values natin are called constants, tensor constants. Then ito yung mga tensors natin. Tensors are just the resulting from a given process, are the resulting weights or parang gradients in a given process. So ayun yung mga tensor. So si A, si B, si 15, yun yung value niya, pero yung tensor is the variable. So tensors are treated as variables in TensorFlow. So ito yung mga processes. So ang tawag sa kanya is tensor ops, tensor operations. So in a neural network, ganito siya. More examples, ganito ang computational graph ng isang neural network. So ganito yung mga pag-flow niya. So mag-flow siya forward yan. Then pag magbaba-prop, ayan yung SGD trainer na nakikita natin sa taas. Ayan. Then mag-update siya, tapos babalik ulit, restart ulit yung computational graph. Alright? So, ano ba yung typical machine learning workflow sa isang machine learning process? So data acquisition, data preparation, model development, training, and prediction. However, ito in production na siya. We have accuracy evaluation. If hindi na satisfy yung accuracy na nimimit natin, babalik tayo dito sa data acquisition or data preparation. So mag-iiba tayo ng pag-prepare natin ng data sa pre-processing or we obtain more data for it. So remember, pag predict mo siya or pag nag-deploy tayo ng machine learning model, kunyari, within 1 year, dapat i-update natin siya, which is called the retraining. So retraining means na we update the weights from the given data. Kasi yung data, hindi naman siya constant eh. May tinatawag tayong problem sa AI or machine learning, which is the data drift. Data drift is as time passes, nagkakaroon ng changes in the data itself. So if you train a model on 2010 data, then 2015 na ngayon, then need mo na siya i-retrain on 2015 data. So yun yung in terms of time. So nag-iiba-iba rin kasi. So sa accuracy not reach, so ganun din, pag retrain, mag-retrain ka ng data here. So possible na mag-retrain ka by obtaining more additional present data since you trained the data on the past. So kunyari, nag-train tayo ng data on 2015, 2017 na, collect tayo ng data from 2016 and 2017, and then i-retrain natin yung model para ma-fix natin yung data drift. So ganun yung mga ganun how a typical machine learning workflow in production. So hindi lang siya basta-basta na-deploy na natin, gagamitin na natin siya agad. Lahat yan needs constant retraining, constant monitoring, and alerting if yung errors niya dumadami. Alright? So here, sa TensorFlow, we can use TF data for data acquisition or data preparation. And TF Keras, ito yung gagamitin natin in this talk for model development and training. So in prediction, yes, covered din natin, pero hindi natin siya i-deploy. I'll just see, i-predict lang natin siya on some sample images. So TF data, so we accelerate data pipelines using TF data. Introduce ko lang sa inyo si TF data. Para introduce ko muna sa inyo si TF data and TF Keras before tayo mag-proceed sa code. So TF data is a TensorFlow API that is especially made using TensorFlow. Using this data makes it possible to handle large amounts of data with from different data formats and prepares the dataset for model building. It is also a fast abstraction API that represents the datasets as tensors. So from the dataset, TF data, gagamitin natin siya as our data pipeline to prepare the dataset for feeding into the machine learning model. So bakit ba kailangan si TF data? Kasi for example, by my experience dati, nung hindi pa ako gumagamit ng TF data, mahirap mag-read ng mga, sabihin natin, 10 gig of data dun sa memory natin. Hindi nagkakasya sa RAM natin yun. So ginagawa ni TF data, ino-optimize na yun na hindi ko ilo-load lahat ng data, pero i-reserve ko siya sa naka-cache. Parang ganun yung ginagawa ni TF data. So fast din siya kasi syempre, if it's under TensorFlow, yung dataset natin are represented din as a tensor. And yung mga pre-processing na ginagawa natin sa kanya is made by computational graphs. Computational graphs rin siya. So, ganun din yung nangyari sa kanya. And then, kaya siya mabilis kasi syempre, gumagamit din ng GPU to load or to process or to pre-process the dataset. So, si TF Keras, it's a high-level model building for TensorFlow. So it's easy to learn API for TensorFlow. It makes building deep learning models easier due to its easy readability and writability. So ang TensorFlow toolkit, makikita natin from here. So we have our TF Keras and estimators. These are high-level object-oriented APIs from TensorFlow. Then we have our reusable libraries, tf.layers, tf.losses, and then we have a low-level TF API kung gusto natin mag-extensive control dun sa model natin or sa ano natin. So, TF, again, can run on multiple platforms, multiple devices, mapa GPU, CPU, or TPU man yan. So, ang TF Keras, may tatlong tinatawag na API. So, we have the sequential, functional, and subclassing APIs. So, for beginners, we're going to use sequential API. This is appropriate for beginners. Each layer has exactly one input tensor and one output tensor. So, papasok ng one input, papasok ng one output. So, pag functional, more flexible than the sequential API, can handle non-linear topology of the neural networks. So kung marami siyang hindi linear na dire-diretso lang, kung magka-connect pa siya sa other layers, pwede tayo gumamit ng functional API. It takes motivation from directed acyclic graphs. So search nyo lang kung anong data structure yan. So sa subclassing, more advanced, can handle custom layers created by the user or the developer. Sa subclassing, ito na yung medyo advanced na ginagamit ng mga AI engineers right now for developing models, especially if they want to customize the function itself. So ito yung sequential API, functional, and model subclassing. So sa sequential, if you want to create a neural network na input, then may hidden layers dito, then output, sequential gagamitin mo. But we have, sometimes kasi may mga data set or may mga deep learning models na the input is connected to 2 layers, then yung 2 layers have some sort of processes going on para maka-generate ng output. Pero these 2 layers are not connected to each other as far as you can see, since different processes siya, different mathematical, different functions. So dun gagamit si functional API. So, si model subclassing, ito na yung ito na yung sinasabi kong magde-define kayo ng custom functions nyo. So, may def. So, under the tf.keras.model siya. So, example ng sequential API for tf-keras, which is nasa example later, ganito lang siya. So, we have our input, then we have our convolutional layers, then ito yung sinasabi kong max pooling earlier, the pooling, then convolutional layers, and then max pooling. So we have a total of 3 convolutional layers there with max pooling. Then we flatten, lagyan natin ng dense layer, and then we have the output layer, which is the number of classes, syempre. So as far as we can see here, ito yung sequential API, para lang siyang nakalist, so it's represented as a stack in a way. So pag punta sa output, punta siya dito, sa layer na to, then dire-diretso lang siya pababa. So pag sa functional naman, we have defined here the input layer, and then we have here yung pag-define ng convolutional layer. Tapos maglalagay tayo dito ng image input. So ito, connected siya here. Actually, it's wrong variable. Sorry, I'd fix it already. So later, I'm gonna show you yung proper code niya. So ito, connected siya here, and then we define again a layer. Then ito, since X is previously here, so i-connect niya lang here. So technically, it's just the same connection. Huwag niyo lang kakalimutan pag gumagamit ng functional API, it needs this kind of notation na after you initialize the layer or initialize a variable that is a layer, syempre, kasunod niya, ilalagay mo kung saan layer siya connected, previously connected to. Alright? So makikita nyo here, sa output, kinonnect natin siya after this X. So, connected na siya. Ito na yung output layer natin. And then, model is equal to keras.model. Inputs is equal to inputs. So, here. Then, output is output. So, makikita na niya since output is connected here. Then, here, ito yung flow ng X na nangyayari. So, pakita na niya na ganito yung summary natin. Ganito yung pag-connection ng model natin. So, for the subclassing API, hindi natin ka-cover sa talk to since medyo na siya, pero ganito siya nangyayari. So, if you want to customize a new layer or your new layer na hindi predefined, so this is how you implement it. So, may call function, and then sa loob ng call na yon, ang input niya, dito mo i-define kung ano yung mga tensor operations na nangyayari sa loob ng layer na to. So, sa encoder, ganun din. So, may init. So, pag in-initialize yung encoder na class, na layer, ano yung mga dapat nandun sa kanya. And then, dito sa call, so it's like object-oriented lang siya in a way. Pero tinatawag siyang subclassing API kasi it builds up from the TF-Keras, TensorFlow Keras modules. So you're just extending, you're just method overriding or overloading yung tawag dito. You can also overload yung mga layers na dinefine ni Keras mismo. So, method overloading and method overriding siya. So, again, before I show you the code, I'll just prepare my code muna. And let's have a short break for a while. So, ayan. And we're back. Hello guys, I hope you had a good break. Kahit saglit lang. So, for this demo, we're gonna use the flowers dataset. So, the flowers dataset is an images around 3,000 to 4,000 images containing flowers. So, currently, as may 5 classes yung dataset natin. So, sunflowers, dandelion, daisy, tulips, tsaka roses. So, from that, let's proceed na sa ating code demo. So, I'll just exit the slides. So, if you have a Google Chrome, if you have a browser, I want you guys to enter collab.research.google.com. So, ayan. If Google Collaboratory, so Google Collaboratory is a basic environment that is provided by Google sa mga developers who want to learn AI particularly. Kasi may free access siya to GPUs. So, zero configuration needed. If familiar kayo with Jupyter Notebook, if matagal na kayong gumagamit kay Python. So, ayan siya. So, if you want to use it, so let's get started here. Example. So, if you want to calculate here, seconds in a day. So, if you want to print hello world. So, ayan siya. So, makikita niyo rin dito na minomonitor natin yung mga RAM natin. Okay? So, currently, how do you save this in your drive? You can save this in your Google Drive. So, ayan siya. You can also save your dataset in the Google Drive and pwede nyo din siyang i-load yung Google Drive nyo para ma-import yung dataset dito sa Colab. So, madaming tutorials online about this. So, ito rin, mga sample visualizations sa data science, sa machine learning, marami pang iba. So, let's proceed to our sample code. So, here. Let's restart and run all. I restart na runtime muna natin. So, we're gonna restart the server muna. So, to guide you lang, be sure na if you want to use GPU sa Colab nyo, punta kayo here sa runtime, manage session. I change runtime type, then check nyo yung hardware accelerator. So, meron din siyang TPU, pero ako, hindi pa ako masyadong gumagamit ng TPU kasi hindi ko pa siya gamay. Kasi ibang types of computation siya. Alright? So, ayan. So, we're gonna import our library. So, we're gonna use Matplotlib for visualization, NumPy for matrix operation, Pillow for image processing, and si TensorFlow. Then, si TensorFlow.keras, i-import din natin siya. So, ayan. So, we're gonna load the dataset. So, yung dataset URL natin, nasa cloud lang siya. So, i-download natin. So, pag dinownload natin siya here, pag niran natin itong code na to, we can use this df.keras.utils.kit file para ma-download natin siya sa ating disk or sa device. So, for this, ayan. So, na-download na siya. Paano natin makikita? Punta tayo here sa folder. So, makikita niyo here, we have flowers. Let's find flowers now. Ayan. All right. All right, wait lang. Let's factor set this. So, ayan. So, as far as we can see, nasa root siya, under keras. Tagal mag-load. Let's wait for it to load now. Alright. It seems that we can access it since due to security reasons. Pero, if gusto natin makita yung directory, technically, it's a folder that contains flowers. So, kada flower, meron siyang folder. May roses / tulips. So, yung 5 flowers na nandun. Alright? So, parang ang directory niya is like, if pumunta tayo sa image specification in TensorFlow, yung directory niya is like this. Alright? So, this, yung mga code ko, it's basically from documentation and code ni TensorFlow, but rather, may mga ibang code lang ako na ine-edit dun to modify and to make it more readable. Alright? So, ayan, pag check natin how many images ang meron tayong 3,670. So, if you want to visualize yung mga nakalaman na sa laman ng mga images na nasa loob ng folders, so, ayan siya. So, then we're here. Ito yung sinasabi ko, nagagamit tayo ng TensorFlow data. We have a batch size, kung paano natin mag-create tayo ng by batches mamaya sa training and validation. Kasi sa model, hindi naman natin pwede ipasok kagad isa lahat. So, tinetrain siya by batch. So, usually, a batch size is a power of 2. So, dito, 32. Depende sa RAM mo or yung sa space ng RAM mo na available kung gaano kalaki din yung dataset mo. So, sa seed, 42. Seed is like a random number lang. So, parang any value siya na gusto mo. Kasi usually, pag nag-randomize ka, random siya. At least, pag may seed tayo, at least yung pagka-random niya, consistent and stable. So, let's create our dataset. So, we're gonna use tf.dataset.this files. So, ang argument na papasok natin dito is yung data directory. So, from this, let's reshuffle. So, make sure here. So, makikita natin dito na yung laman ng list ds na tf dataset nagko-contain pa lang ng files. Diba? Alright. So, from here, so let's print yung class names niya. So, syempre, paano natin malalaman yung label? Kung ano pangalan ng mga folders. So, ganito lang yung ginawa ng code na to. Kinuha lang niya yung directory, then in-split niya. Alright? So, daisy, dandelion, roses, and flowers, and tulips. Then, ito na. So, yung validation size natin is 80% training, 20% validation or testing. So, in practice, training, validation, and testing is different. But in this case, since basic pa lang tayo, training and validation is enough already. So, we treat our validation data, in this case, as a test set. So, 80%, 20%. So, if titingnan natin siya, 936 and 734. So, we have a total of at least 2,936 training data, 734 testing data. So, we want to process the image. Syempre, sabi ko kanina, we have a pair of XY values. So, we need to get the label of a given image from the file. So, syempre, makikita naman natin here, pag nakita natin dito, ito yung kada image, andito yung label niya. Yung label niya, roses, dandelions, sunflowers, daisy. So, basically, that's i-split mo lang siya. Kaya mo makuha using string manipulation, string operations. So, ayan. So, again, then from the image file, syempre, need natin siya i-transform into a RGB matrix. So, merong function si TensorFlow dyan. Then, if meron kang gusto mo i-resize based on the image size na gusto mo, pwede. So, in this case, 180 by 180 yung ginawa natin. Alright. Then, we're gonna combine these two functions. So, given a file path, let's get the label and i-read natin yung file na yon. So, meaning ng tf.io.data from a given file path from a byte na data type, tina-transform niya into a string, to a file name. Then, i-decode natin siya using this function that we declared above. So, ang nire-return niya is a corresponding XY pair given an image and a label. So, ito si TF, auto-tune, tf.data.autotune. Ganit, meaning lang niya, ino-autotune niya yung optimization ng TensorFlow itself from the data to the model. Kasi depende sa RAM mo or sa memory mo, ino-optimize niya yung pag-load ng dataset. So, using auto-tune, At least hindi na natin need mag-define ng arbitrary values here. Depende na lang sa currently available resources ng device mo. Alright? So dito, normalization. So meaning lang yan, di ba, ang values ng isang image is 0 to 255 kada pixel for an RGB matrix. So ang ginagawa lang na dito is kina-convert niya into 0 to 1. Kasi ang 0 to 255 masyadong malaking value siya. Mathematically, if ko-compute natin yung yung mga products, yung mga gradients nun, malaki siya. So at least pag 0 to 1 lang siya, in-normalize lang siya in a point na yung range ng values na nasa loob ng image mo or yung matrix mo is between 0 and 1 already. So, ang ginagawa lang neto, train ds.map and validation ds.map, yung .map function for atf.dataset, is minamap niya lang yung kada element dun sa function na to. Alright? So, i-print natin yung class names. So, let's check kung anong shape niya. So, ang label, ito yung shape, ito yung 1, meaning 1, dandelion siya. We will convert also yung mga labels natin to integers. Why? Kasi, pag sa neural network, hindi naman niya mapakaya mag-process ng strings, right? Kina-convert natin siya into integers. So, ang ginagawa dito is ine-encode natin siya. So, nakita naman natin na list to. So, our array to, 0, 1, 2, 3, 4. So, if we started, we convert lang yung, kung label niya is Daisy, ika-convert natin siya sa 0. Since sa index-based naman siya. Kung ano yung index no label na yun, yun yung equal na integer niya. So in this case, this is 1, so this is dandelion. So we configure our dataset for performance. So before natin ito-train yung model, we want our dataset first to be well shuffled, batched, and optimized into memory. So we can only do this using tf.data. So may link akong nilagay dito if you want to know kung paano ginagawa ni tf.data yun in a deeper sense. So ito, kina-hash niya, then sina-shuffle, then binabatch size niya according to the shape. So currently, by 32 tayo. So yung 2,936 na training and 700 something na data, na validation, dinivide niya by batches of 32. Para ginugroup niya by 30 batches of 32 para ipasok sa model later. So one batch is composed of 32 images. So if apply natin yun dito sa ating tf.dataset. Alright? So let's try to visualize our dataset muna. So if titingnan natin, yung train ds natin na shape, ito na siya, none, 180, 183, from 180, 180 by 3. Yung none, ito yung batch size niya. So, yung none, pag binatch mo kasi siya, nagiging none siya. Kasi pag pinasok siya sa model, depende dun sa batch size na nilagay natin. So, hindi siya nilalagay ni tf.dataset. Kasi sometimes, automatic siya or pwede mo siyang i-optimize. Kasi, if 2,936 by 32, hindi naman, ano yan, yung remainder naman yan. Wala, hindi naman natin sure kung may remainder yan or wala. So, may 91.75 siya. So, meaning, ang remainder niya is meron isang batch dyan na 24 lang yung laman. So, hindi lahat 32. May isang batch na 24 yung laman niya. So, kaya arbitrary value siya kasi technically, ang meaning lang niyang none as a batch size is pag pinasok sa model, alam na kagad ni model yan automatically. So, ayun. So, let's visualize first the dataset. Medyo matagal lang siya kasi kukuha tayo ng 9 values. So, ayan siya. Dandelion. So, dandelion. Tulips, sunflowers, roses, daisy, and daisy. Alright? So, makikita natin dyan later kung paano natin siya gagawin. So, before I go back here, let's check. I'll just whiteboard lang. So, sabi ko sa inyo kanina, sa dataset, ang dataset din, yung mga functions or yung mga maps na nilalagay mo sa kanya, mapping functions, is considered as a computational graph din. So, ano ba ang ginawa natin sa dataset kanina? So, kanina, meron tayong list ds. Alright? So, transform natin siya into list files. Minap natin siya here. Alright? Then from here, naging training and validation siya. Train and val ds. Sorry, apologies lang for my Then from this, ang ginawa natin sa kanya, from train ds, file names pa lang to, meron tayong process image na nilagay. Process image. Alright. Then from process image, nag-normalization tayo. Norm. Then from norm, na ginawa natin tong configuring our dataset for performance. Alright? So, ganun lang yung mga nangyari sa atin. So, pag computational graph siya, ganito siya mangyayari. So, meaning, kapag nag-iiba-iba yung dataset mo sa loob, be careful lang to avoid na paiba-iba yung size ng dataset mo, yung structure ng dataset mo. Pag masyadong madaming functions, mapping functions, dun kayo magkakalituhan. Kasi computational graph to, so hindi lahat kagad gagawin ni TensorFlow. Ibig sabihin, pag kinol ko to si train ds, kahit na map na niya sa kanya yung process image na function, before natin tawagin yung dataset, technically itong dataset pa lang to is naka-cache pa lang yung value niya. Hindi pa siya nakamap. So, kada call natin ng train ds or valid ds, ine-execute nitong mga mapping functions. Ganun yung nangyayari sa kanya. Mas optimized to in a way na hindi lahat kailangan i-load ng TensorFlow into memory, lahat ng dataset na gagawin natin. Alright? So, after nung itong norm, ito yung nangyari, kinash natin siya, shuffle, ni batch, tas pre-fetch. So, technically, continuing, may arrow pa yan pa ganun, as a computational graph. So, pag kinocall natin yung train ds, pag kinol natin siya here, pag kinol natin siya dito, meaning, na-execute yung computational graph na to into the memory. Pero, pag ini-initialize pa lang natin yung variable sa kanya, sinesave pa lang siya ni TensorFlow na ito yung mga operations na kailangan kong gawin. Pero other than that, hindi pa niya, technically wala pa into memory. Kaya if titingnan mo yung RAM here, tingnan natin yung RAM natin, 0.14 gig pa lang yung nasa GPU and almost 1.20 gig RAM pa lang yung ginagamit ng notebook natin. Terminate lang natin itong tutorial. So, meaning, hindi pa nakaload into memory lahat yung dataset, nakasave pa lang siya as computational graph. Then, this computational graph will be executed upon calling the dataset. So, dito, nung kinol na natin yung next batch, dito na siya nag-execute. Kaya nakita nyo, medyo matagal ng onte. So, let's try to time it. Kasi, nung ginawa natin itong code block na to, in-execute niya yung computational graph ni train dataset. So, umabot siya ng almost 2 seconds of execution para i-load yung computational graph and i-execute siya. Alright? Gets? Gets naman? Alright, sige. I'll just erase this first. Pardon me. Alright, sige. So, after ng tf.dataset, let's go na to create our model. We're going to use convolutional neural network. So, image shape, 180, 180 by 3. Then, we have our num classes, kung ilan yung classes niya. So, image batch. So, ayan siya. Ito yung isang image. Alright? Image batch 0. Tapos, if titingnan naman natin yung label batch, ito siya. So, nakita niyo yung values niya, between 0 and 1 lang yung values natin. Walang nagiging greater than 1. So, Ayan, that numpy, shape niya, wala siyang shape kasi one-dimensional array lang siya. So, numpy is equal to 4. So, syempre, ang 4 means image batch. 4 is tulips. Tama ba? Tama ba? Sunflowers pala. Label, wait lang, class names, check natin. We can access the value here. Ayan, tulips. So, tama naman. Ito siya, tulips. So, ayan yung class names natin. Alright. So, ayan. And we initialize the CNN. So, same lang din siya sa picture ko here. Almost the same. Asan yung slides natin? I'll just go back to my slides. Tama naman, kita ba? Naka-screen share ako. Yep, naka-screen share. Alright, ito siya. Itong picture niyan, convolution, pooling, convolution, pooling. However, in this case, tatlong values lang siya. And then nakikita nyo kanina, pataas ng pataas yung convolutions natin. Kasi we want to represent our data. Parang nangyari, from 180 by 180, ni-represent niya yung mga values na to ng paliit. Hindi na magagawa ng convoluted yung information. So, if we check model.summary, we're using sequential API pala for this. Ayan, nakikita nyo. So, nakalist lang siya. Then, after ng convolution, may max pooling. Then, after this, 3 convolution layers, pina-flatten. Then, may dense. Then, may softmax tayo. Softmax is just a sigmoid function, pero for multi-class classification. Hindi kasi binary, madami tayong labels na kinaklassify. Alright, so ganyan siya. Ayan, gets naman. So, from 180 to 180, naging 90 by 90 by 16. Then, 45 by 45, 22 by 22. Then, flatten. Then, dense. Ganito yung mga laman niya. Yung output sheet niya. So, from the input, 180 by 180, ang output niya, after this, is 90 by 90 by 16. And then, ayan siya. Alright, gets? Okay. Then let's compile, model.compile. So we're gonna use Adam. Ito yung parang convex optimization algorithm natin to minimize the loss function. It's a type of convex optimization algorithm. Then we're gonna use our loss function as sparse categorical entropy. So technically, I'll let you Google it, pero yan yung loss function na gamit natin. And if you want to plot our model, we can go here. Ayan. Okay? So before that, let's try to predict first. Try to predict a given sample. Try to predict a given sample. So, kanina meron tayo image batch. So, model.predict image batch 1. Image batch 1, pf.expands. Kasi dapat by batch kung ipapasok natin sa model. So, we're gonna use this. Alright, nakita nyo, nagpa-predict siya. Okay lang tayo. Let's wait lang. Saan naman tagal lang. Ayan. So makikita natin, ang in-output niya is around 5. Arrays of 5. So meaning, ito yung mga values nung index natin. 0, 1, 2, 3, 4. Technically, kukunin lang natin kung anong index yung pinaka-maximum. So tf.argmax. Check natin to. Sample predict. Ayan, explain ko lang habang yung softmax function. Tama ba? Wait lang. tf. argmax. Ayan. Alright. So, from here, let's print a sample to it. Alright, listed pala siya. So, according here, ang pinaka-max is index 0. So, index 0 is class names. Pasok natin siya sa list. Pwede natin yung index. Daisy. So, kanina tulip. Ngayon, syempre, hindi pa natin nat-train yung model. So, pangit talaga. So, explain ko lang bakit ganito. Ang softmax kasi, ang output niya, depending on our number of labels, pero may labels tayo na 5 labels. Alright? So, technically, ang output ni softmax sa neuron is nakaganyan. So, may bunch of neuron dyan. Neurons, neurons, neurons. So, meron tayong 5 softmax here. So, ganyan siya. Alright? So, naka-flatten to. Flatten yung layer. Ayan. Naka-dense pala. Then, yung dense, papasok siya dito sa softmax na 5 layers lang. So, ang softmax is like a sigmoid function. So, ang values nito is between 0 and 1. Hindi pala. Hindi siya 0 and 1. So, ang mangyayari, kina-convert niya lang yung values ng mga neurons, yung mga gradients, into a 0 and 1 value. So, if isinam mo tong lahat, magiging 100 yan. So, probability yan. So, meaning, for the daisy, for the tulip, 0. For the daisy, he is 21% confident since 0 and 1 siya. So, pag tinimes 100 natin, percentage, 21% confident na it's a daisy, 18% confidence is in this label, and what? So, itong label na to, since converted, pag itong daisy, itong neuron na to corresponds to a daisy tulip, etc, etc. Alright? So, ang output niya is an arbitrary value na 0.21, 0.18, 0.20. So, after activation niya. Alright? Tapos, para makuha mo kung anong label yung gusto mo, model.predict lang. Kasi kunin mo lang yung pinaka-argument maximum niya. So, argmax is like, kunin mo yung pinaka-max, then kung ano man yung index ng pinaka-max na values na yon, i-return mo sa akin. Alright? So, ganun lang siya. So, let's erase. So, kapag gumagamit kayo ng binary, sigmoid lang gamitin ng binary classification, isang 1, 2 labels lang, or true or false lang yung ginagawa na value. Don't use softmax kasi parang softmax is just a sigmoid function, pero applied for multi-class. So, if titingnan natin yung logistic function, sigmoid function, ayan yung equation ng sigmoid function. Softmax function, this is softmax. Softmax is just an elevated sigmoid, multi-dimensional sigmoid function siya. So, if titingnan natin, ito yung sigmoid. So, same siya. Ang softmax is like 1 over 1 and 1 over 1 plus e raised to z. Softmax is just the same. Hindi magamit pa rin siya ng a raised to z. So, it's just the same. However, higher dimensional lang siya. Okay? Remember that softmax function is just a higher dimensional sigmoid function. So, if we train the model, i-train natin on 10 epochs, meaning we iterate 10 times on the dataset by batches of 32. Papasok natin si train ds, yung validation natin si val ds, 10 epochs. Alright, medyo 10 epoch siya, so around 7 seconds per epoch. So, hintay lang tayo na onte. So, ayan. So, ayan, may 92 batches tayo. So, if we divide 2936 by 32, ay, may 92 batches na tayo. Yung second batch, yung 92 batch is around 24 elements lang. So, na-train na siya. So, makikita natin, yung, ayan, ganito tawag na training loss, validation loss. So, ito yung loss function niya. Nakita nyo, it's decreasing. I-plot ko yan later. So, yung training accuracy niya, we have around 83.5%. Ang accuracy niya sa validation is medyo mababa. So, let's evaluate first. Let's call the model that evaluate. Compared din sa loss function, ang laki. So, explain ko later. So, let's visualize na lang para mas madali, para di kayo mahirapan. Ay, interrupt. Alright, evaluate. Oh, ayan. So, we have around 62.5% accuracy. Then, we have around 150 loss. Medyo mataas ang loss na yan kasi ang loss is around 0 to 3. Around 0 to 1. Usually, it's mababa lang siya. Hindi siya tataas ng mga 5 or 10, depende. But usually, computer vision. So, ayan, pag clean-up natin siya, nakikita natin na yung loss ng validation, ang layo compared sa training loss. Nakita din dito, yung pinakita ko na graph kanina. So, what does this mean? Na nag-diverge na yung validation loss and yung accuracy sa training and validation. Yung training results sa validation ng results. So meaning, this model is overfitting. The model, the CNN model, might be too complex for our dataset or the dataset is too complex for the model. Makikita din naman, if we inspect our image din kasi kanina, hindi lahat maganda yung pagkakuha. Tingnan mo, mark as tulips, no? Pero hindi mo man lang makita kung asan yung tulips. Diba? Tapos ito may kasamang tao, hindi siya lahat sunflowers. So, may noise din yung dataset natin. So, kaya ganyan. So, let's test our model. So, I'll visualize it. So, it's the same. If I predict ko siya sa next batch, then, isi-show ko siya, naka-argmax pa rin. Ipapakita ko yung confidence. So, sa roses, 100%, may mga naka-classify naman siya na maayos. Pero hindi natin alam kung daisy ba to. Itong picture na to. Ito tulips, sunflower. So, hindi siya sunflower. Mali yan. Incorrect label. Sunflowers, hindi din. Dandelion. O, diba? Nakita natin na sobrang noisy ng dataset. Pero we have a 62%. It's overfitting. But, is it enough? Diba? Madami pa tayong improvements on that. And then, on that. So, parang ito yung sinasabi kong retraining or improvement pag hindi natin nakuha yung satisfied accuracy natin. So, wait lang I'll just terminate this session. Alright. Then dito tayo sa improved version. Let's improve yung model natin. So, let's reconnect to restart factory reset runtime. So, it's almost the same. May dadagdagan lang tayong konting processes on this. Halos parehas lang yung code. Pero dito tayo mag-iba. Alright. So dito, mag-add tayo ng additional functions to improve our performance. So may dalawa tayong ginawang function. We improve our dataset and also we improve our model. So first, ano yung ginawa natin improvements dun sa dataset natin? So we're gonna have data augmentation. So data augmentation, we augment our data na to have a more high quality data or dumami rin yung dataset natin, pwede natin padamihan using data augmentation. So ano nga ba yung ginagawa ni data augmentation? Data augmentation augments our data. Sa images, it's just like it transforms a given image into some rotations, some flips, some zoom. So makikita natin here, yung sample augmentation ng isang image. So like nakita mong ni-rotate niya, nag-zoom din siya. So, may mga various rotation siyang ginawa. Dun sa dataset rotation, usually dito sa tatlo, we have a random flip. Pini-flip niya, horizontal or vertical. Niro-rotate niya. So, but it is random. So, around 10%, ira-random rotation kita or hindi. So, hindi naman pwede lahat. Alright? So, in this case, ginawa natin siya na 10, around 9 augmentations yung kinuha natin. but it can do more. So let's apply it to our data set. Ito left, right, flip up and down, and then random crop. Then makita natin here, ini-normalize pa rin natin siya. So, ayan. So, ni-repeat natin siya ng 3 beses. So, meaning we augment the dataset 3 times using this map function. Kasi that map, pag map siya, pag nilagyan mo siya ng repeat the mapping 3 times. So, from 2,936, naging halos 8,808 na dataset na siya. So, let's try to view. Ganun pa rin naman siya. It's the same. So, makikita natin later, ito yung mga ginawang augmentation niya. Mapapansin naman natin, pag visualize natin yung dataset, may mga various rotated. Itong sunflower, ni-rotate niya. Mas okay din kasi yun, kasi we need to train our model then on different orientations ng given image. Hindi porket nagbigay tayo ng sunflower, mamaya kasi masanay si model na, nakita ko tong sunflower na ganito lang yung orientation niya, ganito lang yung quality niya, ganito lang yung pag-zoom niya, ganito lang yung orientation, yung landscape niya. So, at least, mas maganda, data augmentation does is, it augments the dataset na ito ay different orientation. It maps the given element in the dataset into different types of orientation. So, automatic na siya. Hindi natin siya kailangan i-edit isa-isa na ino-augment natin. Pero, parang letters lang yan. Sa handwriting or sa OCR, ganun din yung ginagawa nila. Kasi, kahit sabihin mong isang letter lang yan, need natin ng maraming letters or maraming orientation of that letter na naka iba't ibang position. Diba? Para matuto din si model. So, ito, sa model, we add a dropout layer to minimize the overfitting of the model. So, same siya. Ang inad lang natin is dropout. So, what is the dropout? What is the dropout function? So, i-google na lang natin yung picture niya. Dropout layer. Dropout layer means lang, kung nilagay natin dito is 0.2, meaning 20% ng models, ng neurons, dun after napapasok sa layer na to, it will drop. Hindi niya tatanggalin, but it will have a 0 activation value. So, ganyan yung nangyayari. So, connected siya na ganito. After applying dropout, tinatanggal niya yung connection. At that loop lang. So, random siya. So, sa next loop, ibang dropout naman yung ginagawa niya. Alright? Ganito lang yung nangyayari. Kinikill niya. Hindi niya tinatanggal completely. Nasa neural network pa rin siya. Pero hindi niya na sinasama sa forward propagation. So, syempre, pag too complex, pwede natin bawasan yung connection sa neurons kasi mamaya pag nakakonect lahat, too complex siya. So, ayun yung ginawa natin improvement. Mamaya kasi, our model is too complex, our dataset is too complex. So, ginandahan natin yung dataset. Tapos ginandahan din natin yung model. So, as you can see, it's just the same. So, yung learning rate natin kanina, medyo mataas din. So, itong learning rate optimizer is yung tinatawag na learning rate. So, it's around 0.001, 0.00001. So, depende. It means lang yung learning rate, how fast the model learns. Mamaya kasi, pag masyadong mabilis siya natuto, may mga nakakalimutan siyang natututunan or information na hindi natututunan masyado because of the fast learning rate. Now, if you put your model learning rate too low, masyado naman matagal siyang matuto. So, kaya sinasabi ng experimentation, you guys need to find the right value for these kinds of stuff. So, kung mababa yung learning rate niya, kung nakita niyo masyado siyang mababa natututo, pwede niyo increase. Or if sa tingin niyo pag in-increase niyo, pumapangit na siya, edi taasan niyo na lang yung epochs niya. Alright? So, it's the same pag visualize yung model. And another this here is model checkpoint. Ang meaning na model checkpoint, mamaya kasi yung best na model natin, run ko lang mamaya kasi yung model natin, kahit 10 epoch siya, yung best model na nakikita natin is around 8 epoch lang. So we want TensorFlow to save yung pinaka-best model na yun. Based on validation accuracy. So ito meaning, sinasabi natin kay TensorFlow, what we're saying to TensorFlow is, please save the best model with the highest val accuracy using the monitor and the mode max argument. So meaning save best only. Yung pinaka-best model based on this validation accuracy, isave mo. Yun yung isave mo. Kasi usually kanina, sinasave lang natin dito is yung last model. Yung last model after the 10th epoch. But in this case, ang sinesave niya is the model with 10, with the best validation accuracy. Alright, so actually, it's the spoil na. So around here, we have reached around 60+% accuracy in a way. It's the same, pero makikita natin na magkalapit na yung validation loss and training loss. So this is a good kind of plot already. Na magkalapit yung training loss and validation loss. So nakikita natin na hindi pa nagko-converge or hindi pa nagda-diverge yung loss, training and validation loss natin. So what we can do on the future is train this more on more epochs. Gawin natin 20 epochs, ano kaya mangyayari? Gawin natin 30 epochs, ano kaya mangyayari? So, or if dagdagan natin ng convolution layers, ano kaya mangyayari? Alright. So let's call lang ulit sa module at evaluate. Oh, ayan. Alright. So, nakita natin na medyo umokay siya, na mas malapit compared sa nakita natin dito na sobrang taas nung niya. So, what happened here is, yun nga, in-improve natin yung model to prevent overfitting. Though, yung accuracy niya, mas 2 to 3% less compared here. Dito kasi umabot tayo ng 62.53%. So, parang at least ito, it's less overfitting. Hindi naman porket sinabi na mataas accuracy ko dito, hindi na maganda na siyang model. We have to check it then if the model is overfitted or not. Kasi remember, we're not using this in the real world scenario pa. So, mamaya kasi, in this case, mas mataas to. Pero pag dineploy naman natin to, since overfitted nga yung model based from the plot, hindi siya maganda i-productionalize. So ito, pwede pa natin i-improve. So sabihin natin, let's run this on another loop. Mamaya, gumanda pa siya. Let's train it on more epoch. Right? So dito, makikita natin na nagda-diverge na rin siya around third epoch, around fourth epoch. Pero sinave pa rin ni TensorFlow yung may pinakamataas na validation accuracy. Diba? Alright, so let's try to predict already. So here, ito, mas gumanda yung results niya. So makikita nyo kanina, paano malalaman kung sobrang overfitted din? Makikita nyo yan eh. Kung yung confidence level niya, puro 100% mostly. 100%, right? Eh, ang model naman, di naman gano'n ka-confident magbigay ng values eh. Kahit tao nga eh, sometimes hindi ka sure kung ano tong mga pinapredict or kina-classify natin. So at least dito, mas okay yung mga numbers niya, na yung mga confidence scores natin, medyo maganda siya, in a way. Diba? So, ito, tulips, daisy, sunflower, and tumatama naman. So, and that's how we do data preparation and model building with TensorFlow 2.0. So, do note, again, remind lang na we're using TensorFlow 2.0 here. If gusto nyo gumamit ng TensorFlow 1, mas okay. Pero, I'm gonna say to you na as early is that iba yung code ng TensorFlow 1 compared sa TensorFlow 2. Sobrang laki ng changes niya in a way. So, I guess for beginners, it's better na you start with TensorFlow 2 na agad kasi in TensorFlow 1 medyo hindi pa siya ganun maganda siya, pero mas easier, mas user-friendly for beginners on TensorFlow 2. So, alright, kung gusto nyo, you can play this code. I'm gonna be sending this to organizers, yung code na to. So, around here siya, nasa Google Drive natin. So, do note na yung code pala nito is obtained lang from the TensorFlow tutorial. However, may mga ibang makita. So, may mga konting difference siya na inayos ko na. Or mas inayos ko to make it more readable. Alright. So, okay. I'll go back to my slides. Leave ko lang ito. Alright. So, after this, we're done already. Alright. So, related resources. So, if you guys want to learn more about AI, of course, I always allot some time to discuss yung mga resources that you guys can use for learning AI. So, towards accessible AI education. So, currently, in our field today, maraming AI tutorials sa YouTube. Ang mahirap lang, madaming people that is scared of AI because yung math nga, heavier. Aminin natin, I'll be honest with you. AI is math heavy. Hindi ko need na magaling kayo. You guys just need to learn to appreciate math. So there's Coursera, madami sa Coursera, and ito si Andrew Nang. He's known as one of the best AI educators out there. He's one of the best AI teachers out there. Madami nang naturuan si Andrew Nang na successful AI engineer right now. Hindi ko alam kung successful na ako. Pero yeah, I'm still 2 years into the field. I want to do more pa. Pero he's also one of my educators out there. Hindi ko pa siya nakakausap, but we met them last December through a live video conference sa AI Pilipinas. So yeah, AI Pilipinas is also in partnership with Deep Learning AI. And then Stanford University, sa YouTube, lahat ng AI machine learning videos or lectures nila nasa YouTube. If hanapin niyo lang. So for learning resources sa mathematics, andyan si MIT, si Gilbert Strang for linear algebra. Kailangan niyo ng linear algebra. Probability and statistics, mathematics for machine learning na libro, mathematics for machine learning na Coursera, then calculus, ito yung mga need nyo. Differential calculus, integral calculus, and differential equations. Only the basics. If you guys want to pumasok sa AI field, need talaga siya. Pero if you guys are just developers who want to use AI pero hindi nyo matutunan, it's fine. So for machine learning, andyan si Stanford Machine Learning, Applied Data Science, and andyan si Stanford CS229 na nasa YouTube. Nasa YouTube yung mga videos nila here. Then si Google din, meron machine learning crash course. If you guys want to learn machine learning ng mabilis, like basics lang or overview. Then for deep learning, neural networks, we have Stanford. Puro Stanford yan. CS230, yan yung mga first codes ng Stanford na nasa YouTube. Just pahanapin nyo lang yan. Nasa YouTube lahat yan. I promise you. So, deep learning AI, marami din courses. So, TensorFlow and tutorials. Alright, shameless plug. Alright, since we're done with the talk, I urge you guys, or I invite you guys to join AI Pilipinas. AI Pilipinas is an AI community here in the Philippines, and we aim to empower the AI community by providing AI support, AI guidance to those people who want to learn AI. Alright? I also have my GitHub here, LinkedIn, Facebook, Twitter, and you guys can reach me through my email if you guys need some guidance on artificial intelligence. For yung mga research, yung mga thesis nyo, mga mobile apps nyo na ginagawang AI, I'll try my best to help you with that. Alright? So before we end the recording, I'll just finish this with a quote from Alan Turing. We can only see a short distance ahead, but we can see plenty that needs to be done. So currently, our field is fast-pacing in AI. Madaming ang bilis ng pace ng research natin. Pero we can only see a short distance ahead. Makita natin na despite these innovations, marami pa din kailangan gawin. Marami pa tayong hindi pa tapos. Humanity is not a perfect community. Pero we're always doing our best to innovate, to improve ourselves. So, ayun na guys. So, thank you very much for listening to my talk. Kahit medyo mahaba siya. It's one of my longest talk out there. Pero, I really appreciate you guys. If ever you guys are watching, I appreciate that you guys are watching this. Alright? If you have any questions, I already left. You can just pause yung slides ko saan ko iniwan yung contact details ko. And you guys can reach me through there. Alright? So, yeah. Thank you guys.